Alright, so now we are back for video number 3 for section 2.1. I'm trying to keep them semi-short for you so that you can go through each of them quickly. We start out with the definition of a function rule. A function rule is an equation that represents an output in terms of an input. Okay, that sounds really complicated, but here's all it's saying. Here's an example. I've got y equals 3x plus 2. Okay, this is my output. It is written in terms of an input. Remember, when it says in terms of a variable, that just means you're going to have that variable somewhere in the problem. So I have my output over here. My input is over here, but it's got some other numbers with it. I've got a coefficient. This time I've got something added to it. Okay, function notation. Here, this is just getting technical. This is saying instead of y, they want you to use f of x. So if we take this problem above and rewrite it in function notation, it would be f of x equals 3x plus 2. Now, the f of x stands for function of x. All that means is this output is going to change depending on what you plug in here. So this answer is a function of this variable. The other thing, sometimes they won't use f of x. Sometimes they will use g of x or h of x. It's all the same thing. It's just using different letters. Sometimes they put different variables here if they've got several functions listed together, and it just helps you, differentiate between the two or three or however many there are. Okay. All right, next. All right. Here's where we're going to see substitution using function notation. And this is something you know how to do, but a lot of times when people see it written like this, they get confused. So I'm going to show you out here to the side what it is you're actually doing. Okay, it's like you're making one of these XY charts. Here's your X, here's your Y. But instead of Y, they're using f of x. Not a big deal. So they're saying find f of 1. Well, notice that 1 is in place of the x. Instead of f of x, it's f of 1. So that means when I plug in 1 for x, what y value or what f of x do you get? So when I plug a 1 here, 3 times 2 is 3, plus 2 is 5. You all know how to make a chart like that. Plug in your x's, solve for your y. Or in this case, solve for f of x. Well, this is the exact same thing. This is the answer we're going to get. We're going to get a 5. We just write it differently. This is f of 1. Take out your x, put a 1 in its place. I'm just going to bring the f of 1 straight down. 3 times 1 is 3, plus 2. Bring your f of 1 down again. So f of 1 equals 5. This was my input. This was my output. Same thing over here. This was my input. This was the output. Okay? So if you don't like to look at it like this, do it this way. The other thing I need you to realize for this problem is that that represents an ordered pair. That is the ordered pair 1, 5. Input, comma, output. Over here, the same thing. This is an ordered pair, input, comma, output. Okay, it's different representations of the same thing. All right, moving on. A couple more definitions. We've got to talk about two different types of variables, an independent variable and a dependent variable. So an independent variable. This is otherwise known as your input. Notice independent starts with IN, input starts with IN. That's how you can remember it. But your independent variable is the variable that you plug in for. And for the independent variable, you will be given it, you'll be given a value, or you can pick your own. Right, your dependent variable is otherwise known as your output. And the dependent, this is the variable you're going to solve for. Okay, so here's what we know about it. Its value will change depending on the values you plugged in for the other variable. Okay, and I want you to pay real close attention to this word right here. Its value will change depending. Okay, dependent. It's going to change depending on the values plugged into the other variable. Alright, so problem 5. Here, they give me a function, it's in function notation, for f of x equals, that is a negative 2x plus 5. What is the output for these inputs? So I'm going to plug numbers in for x. This is what I'm going to get out of it. So the numbers I'm going to plug in, these are my inputs, are these. And I'm going to solve for the output. So when I plug 3 in, that's negative 2 times 3 plus 5. That gives me negative 6 plus 5 is negative 1. When I plug in 0, I have negative 2 times 0 plus 5 gives me 0 plus 5. Let's try that one again. Equals 5. So when I plug in 0, I get out 5. And the last one, it's a fraction. And yes, you're going to have to work with a fraction. Take my negative 2 times 1/4 plus 5. When I multiply negative 2 times 1/4, I get negative 2/4, which reduces to negative 1/2 plus 5 When you add those, you get 4 1/2. Or you can say 4.5, you could make it 9/2. Okay. By plugging in these inputs and solving for these outputs, I now have points I could plot if they asked me to. Okay, this should be familiar to you. Maybe not the f of x. You should have seen it, but may not have done a whole lot with it. But it's just y. So now the got it question at the bottom, f of x equals, and again that is a negative 4x plus 1. What is the output for the given inputs? Go ahead and pause the video, work those three, and then come back. Okay, I'm going to go ahead and work them out here, but like I said, you can pause it so that you have time to do them on your own. So plug it in. Negative 4 times negative 2 is 8, plus 1 gives me 9. So my input is negative 2, my output is 9. When I plug in a 0, negative 4 times 0 is 0, plus 1 is 1. So when my input is 0, my output is 1. And now when I plug in a 5, negative 4 times 5, that gives me negative 20, plus 1 is negative 19. So when my input is 5, my output is negative 19. All right, and that is all for section 2.1.